Well, afternoon, everybody. Happy September. It's amazing how much of the month's already passed. And welcome to this month's Mozzie Tech Talk. This month, we're going to be talking about something that we've been experimenting with over the past couple of weeks that I think you may find valuable if you've been working in an environment where you're using machine learning models in production and you've noticed that they've started to lose their performance. So we're going to talk about what to do and how to architect a system where you can start introducing model retraining loops. And often what's required is that you actually take the data that you've been using in production and add new labels. So we'll show some examples, we'll show you how that might work, and we'll give you some practical tips for how to use Label Studio and build that into your workflow. I'm Seth Clark, head of product here at Mozzie, and we're excited to bring this month's Tech Talk to you. And if there are other topics that you find you have questions about, other things you find interesting, other things you'd like to learn about, please let us know. We're actually really eager to keep putting content out there that data scientists and machine learning engineers will get value from. So thanks for watching, and let's get started. So first off, I want to say congratulations on the launch of your new product. You just launched a brand new application called the Vacation Photo Sharing app. It's a really simple app, but a great UI. And what it allows you to do is take photos of the different locations that you go to for your vacation. And then when you upload those photos to the vacation app service, it puts them on a map, and then you can share that map with your friends and your family or on social media. So it adds a really fun little kind of mapping component to what otherwise would be a normal photo sharing app. So now that's great in most cases. The way it works architecturally is users will upload pictures, maybe from a smartphone, maybe from their computer, to the vacation slideshow app. And then your application will save all those pictures to a data lake. And then that data lake will then get called upon to show those pictures when folks click on them. This is great most of the time because modern cameras, smartphones and other digital cameras will include the information about where that picture was taken right within the picture metadata itself. So in a lot of cases, the mapping can happen almost automatically. But one issue you've noticed is that sometimes if you're uploading old photos or scans of images, or the data was just corrupted, that location information isn't available. So because you're a machine learning engineer, you had the brilliant idea to add in a machine learning model that will scan all those images and predict where in the world they were taken. And here's how this works. Once the images are submitted to your app, if the location data isn't included, you can send that image over to a model that does image-based geolocation. And once it's gone through that process, it'll return a location. In this case, we're predicting the picture was taken in Lisbon, and that data can get then stored to the database, and we can now map your photos no matter where you took them or what kind of camera you used. Now this works out most of the time, but every once in a while, even this has issues. Sometimes the model gets it wrong. So what do you do in this case? Well, the answer is typically you need to improve your model. And the great part about your app, and one of the reasons why it's a prime target for retraining, is that you've been capturing all of the data along the way that you'll need to improve your app. Because every time a user uploads a picture, that's a new opportunity to learn something new. And to teach your model a new insight. So we've got all this data in the data lake. We have this model that does image-based geolocation. How do we actually take all this stuff, put it together to improve your model and train a new version? Well, that's what we're going to talk about today. So what's great about your production data and the predictions from your model is that they're basically creating predicted labels. Every image that's going through your model is getting a result, getting a prediction. And those predictions are basically the labels that you would otherwise need to train a new model. So what we're going to do here is create an architecture where as the images are going through your model, we're doing two things with them. We're going to be saving them to a data lake, and then we're also going to be viewing the results and getting access to the results through our model observability platform. Finally, the prediction information plus the actual images that are in your data lake are going to be queried within a data labeling tool. And that data labeling tool is where you can fix mistakes. That's where a data labeler, a human in the loop who really can actually look at these pictures and make those corrections, will be able to say, yes, this is correct, no, this was incorrect. That that final step of labeling the incorrect images is what you need to create a new, clean, sort of perfected data set that you'll use to retrain a new version of your model and deploy it back to Mozi. So what we're going to look at in today's Tech Talk is really how do you set up this half of the circle? How do you take those results, save the information, and then connect it back into your labeling tool? And we're going to be doing that with 3 tools. We'll be doing that with Mozi. Mozi will be our model serving tool and our model observability tool. We'll be using Dropbox as our sort of makeshift data lake, and they'll be using Label Studio to actually label these images. So I'm going to shift over to the actual demonstration, and we're going to take a look at some code examples to show you how this might work for your app. So let me switch over here to Visual Studio. Okay, so the first thing that we're going to do is just show how you might set up running your images through a model and saving them to a data lake. So I've created a simple script here that kind of represents what your mobile app might be doing, taking uploaded images, saving them, and processing them through a machine learning model. So we're going to be sending all of the images in this image test folder through a loop that does 2 things. It goes ahead and it sends the image to Mozi for an inference. And then once it gets a job ID, basically an identifier that will allow you to call back the prediction generated, we're going to save the image to our data lake using that name. And that creates a key value pair that we can use to pull those 2 pieces of data back together in the future. So here we have in our image test folder 1, 2, 3, 4, 5 pictures. And we're going to go ahead and send them through this model. So let me go ahead and run this. Python 3. There we go. And what this should do is we should see 5 different line items once all of these images have been submitted for all of the predictions that are being made. All right. And once that is done, we should be able to go and see these images in our data lake and see the predictions within our inference tool, which is Mozi. So the first thing I'll do is head over to the project that we created for our vacation slideshow app. This creates a simple way of organizing and grouping together all of the data that's related to your application. So we can see we got this slideshow app that's made of 130 predictions over the past month or so, and we can actually look at all of the historical predictions. So I'll pull up this one right here. This is one of the pictures that we just sent. Once we open this up, we can see that this was classified as being in Amsterdam. So excellent. In fact, if I jump back and take a look at this picture, this is jsafsoon.jpg in our image folder. That's this picture right here. We can see indeed that looks like what you'd expect Amsterdam to look like. We're seeing a nice bicycle, Dutch-style bike, and a canal with some boats on it. That looks about as Dutch as I could imagine. So that was a correct prediction. That's great news. Now let's check and make sure that image was actually saved to our data lake. So we'll jump back over here, and now we're going to take a look at Dropbox. And here we are. We can actually go ahead and see that all of these images have indeed been saved. And so here's that same picture. Now, what's important about this is that you'll notice this picture has a new name. It's got this sort of big alphanumeric name that's being used to save this image. Why is it named that? Well, it's named that because that's the name of this job identifier. If we scroll up here, we can see this job ID matches the name of this image. And we're going to use that information in just a second in order to pull all of that data together for relabeling all of our predictions in the event that we see our model needs to be retrained. So I'll jump back here to our projects one more time, and the other thing I'll show you is that you can also use explainability to help get an insight into how your model is making its predictions. So I'll go ahead and head back to that that image of the bicycle. Let me see here. I'll jump back over here, and here's that Jace photo. So here we can see a pixel mask that is being applied to this image to identify the collection of pixels that were most influential in predicting that this was a photo of Amsterdam. Interestingly enough, it's finding some corner piece of the roofline here, It didn't identify the bicycle or the canal as being instrumental in this prediction. So as a data scientist, this might be useful information to key on and say, hey, listen, this model is basically making its predictions using the wrong features. It's not looking at the correct stuff within this picture to work. So this might be a really good piece of information that I want to use to help retrain my model. But the good news is it was correct. So I'm going to go in here and actually add in this upvote to confirm that this model indeed did make the correct prediction in this case. We can go and look at some of these other examples and do the same sort of thing. So we'll see here, this is an image that was classified as Cairo. This is actually correct as well. So we'll go ahead and submit that. And then we'll take a look here. Actually, I want to look at one that I believe is a mistake. Yeah, this is actually a picture of Dallas, classified as Chicago. So we're gonna say this is incorrect. All of this data that you could be either collecting from humans who are reviewing these predictions, or you might collect directly from your app. If you recall, we'll have the option of returning to the user the prediction of where this image came from. Your actual mobile app user could be the source of this information to say whether or not the prediction was correct. This information is going to be really important because then we'll use it to identify which images, as well as what percentage of images seem to be correct or incorrect. All right, so now we've got a bunch of predictions. That's excellent. And we also have a bunch of pictures saved to our data lake. The next thing we're going to want to do is pull all of this information into a labeling tool so that we can create a new data set for model retraining. So let's go ahead and head back to our code and we'll take a look at the script that we can run to do that and what it does. So I'll jump over here to import annotations. I'm going to close this up so we can see the code a little bit better. So what we're doing here is looping through all of the images in our Dropbox folder, and then we're going to add all of those images to a dictionary. All of that information will then get queried against our inference results in Modsy to create a big data object. And this is the data object that we're actually going to be using to send to Label Studio. If you're not familiar with Label Studio, it's an open source data labeling product. Let me pull it up right here. It gives you a whole bunch of tools and capabilities to label different types of data. And so there's support for imagery data, text data, audio data, structured data. You can label almost any type of information that you might want to classify or predict with a machine learning model. So this is an instance of Label Studio I've got running on my laptop. This could be something you run within your organization, within the company that built your app, but we'll just show this example on my local laptop. So what we're going to do is take those images, take the predictions that we generated, and then send all of that data to Label Studio using their API. So we'll go ahead and send this to my local host here, and we're going to send it to this project number 1 that I've created. So let's go ahead and run that model. Do Python 3, import, not model, but run this script. And this should go ahead and gather up all this data and send it over to Label Studio. And there, that should be complete. So we'll head back here and we'll refresh this page. Excellent. So here we go. What we can see now is that we have 5 separate labeling tasks that have been imported to our labeling tool. We can see the image that was imported, and then we can also see this predicted value field. This is something that we created directly from the results that are saved in Modsy. So if we look at this a little bit closer, let me go ahead and open one of these up. What we can see is the original image that was submitted. We can see what the predicted value was with 100% certainty. That was the model's confidence that was returned. But we can also see that this was marked as incorrect by one of the human users in Modsy. Again, that could have been a data scientist, another human in the loop, or maybe one of your users basically told you that the model made a mistake. So this is key information for a human labeler, so they can actually go back through this process and take a look at all of the classes that are available. These are all of the classes that your model has been trained to identify, and they can go ahead and fix this mistake. So right now, this image is being classified as Chicago, but really we want to teach the model that this is an image of Dallas. So we'll go ahead and change this label and click Submit. If we take a look at some of these other examples, we can see here, for instance, this is an image of Athens. You can actually tell it's a little Greek flag, a good giveaway. And in this case, only a 78% certainty, but this is actually correct. And so we can scroll down and we can actually see that Athens is already selected. Now, how did we do that? Well, we did that by structuring that data object that we created a second ago in a way that Label Studio could understand. And so you could think of that in a sense as using the predictions generated by your model to preemptively label all of these images. And so because this is correct, we can go ahead and submit this, and we'll do the same thing for all of these other examples. This is in fact London, Europe, so that's great. We'll confirm that. This is in fact Cairo, Egypt. We'll go ahead and submit that. And this is in fact Amsterdam. So that speeds up the process for actually labeling this information significantly. And the other nice thing is that the way that we've set this architecture up, we didn't have to move these images around. This image is still saved within our data lake. We're actually just providing a reference to this image. So our browser is rendering it, so it's easier for human reviewers to do this labeling process. But the image has not been resaved in a new location or a new format. We're still just directly pulling the image from where it's currently saved in Dropbox. All right, so we've done our labeling task, and we've confirmed or corrected all of the labels here. So what we might want to do now is actually take this data and use it to retrain a model. Well, one of the nice things about Label Studio is you can just export this data directly in a number of different formats. So what we'll do is just go ahead and export this as a JSON object, and go ahead and open it up. And after I reformat, we should be able to see how all of this information is structured. So we can see the ID of the task, we can see the actual classification that was used, and we can see the ID of the image. The last piece here, I believe, at the very bottom, there we go, will be the URL of the actual image itself. And so this information then can be extracted along with the class that was identified and selected for this image to create your new retraining data set. And then that information can be cut up, can be split, can be merged with the original training data set, however a data scientist chooses, in order to create and improve this model over time. And once that's done, you can actually then deploy that model back to your serving inference. So if we go back to this this image-based geolocation model, and go ahead and head over here, what we'll see is this is the model that we submitted everything against. We've actually already deployed a new version of this model. So this is version 1.01, and it's actually a significant improvement over version 0.0.1. So that's kind of how you're able to connect the loop back on this whole system, using your predictions, using the production data that you've already captured to create a new data set much faster, much more economically, without a lot of extra work and labor on the human processing side to get that data. One other thing I just wanted to show you is, what did we have to do to actually set up this project within Label Studio to make this work? Well, one of the key things that you'll need to do in order for this example to work is you have to customize the labeling interface for your particular use case. So we've done this for image classification. You can see here the way that we've got the UI set up shows an image and then shows a set of classes that you can use to label this image. I'm actually going to show you the code that we wrote to do this. Label Studio provides support for a markup type syntax, kind of an HTML type format that you can use to work with specific variables that Label Studio allows you to work with. So what we've done is created this first element is an image, and the value itself is image, which we used to create our original data object. So when we look back over here at the script we ran to import our annotations, we actually went ahead and created a data element called image. So within Label Studio, you can use these $ queries to actually kind of similar to jQuery if you've ever worked with that, to pull this data out of the data object that's sent, and then it renders it right here within this box. We did a couple of other things where we're pulling in the model prediction, and that's how we got it to tell us what the actual class that was originally predicted. It shows up right in this section. And then finally, we're able to include a URL in case you want the human labeler to be able to look at an explanation, to look at that pixel mask for each of these predictions. And then finally, we just included a list of all of the classes that this model has been trained to understand. So by formatting this kind of markup file, that's what allows us to actually render all of the data from both our production data lake as well as our model inferencing platform. And that's what creates this layout right here. So that's everything we want to show you. Hopefully this was a helpful guide to give you a sense as to what it might look like to create an architecture for taking production data, for taking production results, and then creating a loop and a pipeline that will make it a lot easier to train new model versions in the future. If you've worked with Label Studio before, you'll know there's a whole bunch of features that we really didn't touch on. I just wanted to show how you get started, kind of how you can approach this problem from the beginning. But it supports a huge range of additional data formats. If you're working in natural language processing, there's a lot of excellent tools for letting you segment specific portions of text, highlighting keywords that were most important in making predictions. With audio files, it's got filters and tools to let you identify specific portions of an audio file that relate to a certain word in English or another language. So the opportunities are really broad, and you can apply this architecture, the same mental model, to almost any type of model and any type of data. Now, if you're interested in playing around with this code, we've actually, let me share my screen one more time. We've actually made it available on GitHub. So you're more than welcome to go ahead and fork this code, play around with it. We've got documentation here that shows you how to actually set up Label Studio, Modsy, and Dropbox in order to sort of recreate this whole example. We love your ideas and experiments, and if you have some suggestions of other features within Label Studio that would be fun to include in this, submit a pull request. We'd love to get your feedback. But thank you so much for the time. Hope this was helpful, and we will see you at the next Modsy Tech Talk in October. Have a great day, and we'll talk to you soon.